Let's talk about the aromatic compounds, aromatic hydrocarbons. The last category that you're going to get familiar with. Aromatic compounds are cyclic and they have normally 6 carbons, but we can have different types of carbons. We just focus on 6-membered hydrocarbons. There is a double bond between every other carbon between 2 carbons. So you have double bond, single bond, double bond, single bond, double bond, and single bond. And then again, if you're going to organic chemistry, you will learn this is called a conjugated system. So when the bonds are repeating one after each other, single, double, it's called a conjugated system. Anyway, you don't need to be worried about this conjugated system. The aromatic compound with 6 carbons is called benzene, without any branch or anything. It's called benzene. This is another way of showing benzene. Instead of showing every carbon and hydrogen, you just show carbons. You show and you don't show. You just put a hexagon, and these dots at the end of the lines, at the angles, they are carbon atoms. And you don't show the hydrogens, you just show the double bond. And the most famous form of benzene ring that I'm sure you all have seen them before is this. Instead of showing all the double bonds, you show a circle. It shows that these double bonds are constantly moving, like a hamburger bun on top of the hamburger itself. So we have a combination of sigma and pi bonds. So you see, for double bond, we also said we have a sigma. So that's the structure. We're not worried about the structure. We have some, because aromatic compounds, aroma, I told you, it means a smell or flavor or fragrance. You can imagine that we have them also in food. Something like vanilla, vanillin, or cinnamon, coming from cinnamaldehyde. They all aromatic compounds, but aromatic doesn't mean necessarily good smell. Sometimes they stink. So the flavors, I told you, vanillin, cinnamaldehyde, and benzaldehyde for the element also. They are the aromatic compounds. So now you know briefly about alkanes, alkenes, alkynes, and aromatic compounds. It's time to start naming. We will name. We will name hydrocarbons, and our focus is on alkanes, alkenes, and aromatic compounds. Okay, ready? So make sure you have slide number 50 in front of you. Slide number 50. Naming hydrocarbons. We need to take some steps. First of all, the first step is to determine the longest chain of carbons. For example, let's say we have this. Longest chain of carbons has how many carbons? 1, 2, 3, 4, 5. And longest chain is not necessarily a straight chain. So don't think like the longest chain should be straight. Sometimes you need to fold it and bend it a little bit. You have a question in your exam review, you will figure it out. Now, we numbered the carbons, but closest to the branch. In this case, if you number the carbons of the longest chain either from left to right or right to left, your branch falls on the 3rd carbon. So let's number from left to right. Then you need to mention the location of your branch. Which carbon is it? The third carbon. Between every number and letter, you need to put a dash. What is the name of your branch that you were supposed to memorize? A CH3 is called a methyl, right? In the first video, I asked you to memorize them. 3 methyl, so it means that there is a methyl group on the third carbon. And there is nothing else, no other branches. So how many carbons do you have in your longest chain? 5. 5 is pentane. This is another thing you should have memorized. So means that there is a methyl group on the pentane on the third carbon. If you have more than one branch, you need to mention all the numbers and the names. For example, I give you 2 more examples to realize it. If the branches are the same, so let's work on the same pentane molecule, but add one more branch. CH, CH3, CH, CH3. Wait a minute. Because I want to be the same exact. I missed the CH2. 1, 2, 3, 4, and 5. Okay? Now, the longest chain is still 5. So which side gets to the branch first? Left to right, your branch is going to fall on the third carbon. But right to left, your first branch is going to fall on the second carbon. So this time, let's number from right to left. Where are your branches? On the second and on the third, right? So you say 2 and 3. So if you have more than one branch and you're going to write the numbers should be separated by a comma. 2 and 3. What are the branches? Both of them are methyl branches, right? So you have to mention, I have 2 methyl branches on the second and the third carbon. What is 2 in chemistry? Di. Di, what is the name? What are the names? Methyl. So 2 and 3 dimethyl, and the branch is a pentane. Okay? So whenever your branches are exactly the same, you need to bring a prefix, di. If you had 3 methyl groups, you would say tri. If you have 4, you would say tetra. If you have just 1, you have 1 number and you're not worried about it. You don't bring mono. What if our branches are not the same? CH3, CH3, CH, 2, C, CH2, CH3, CH, CH, CH3, and CH2. Should be enough. Okay. Now, the longest chain again has 5 carbons, right? Which way gets to the branch faster? I'm sure you'll say from right to left. So 1, 2, 3, 4, and 5. Okay? Now, what are the branches? There's a methyl group on the second carbon, and there is an, you remember this? There's an ethyl group. So, in numbering, you go by the closest to the branch. But in naming, we have to go with the alphabetical order. So which one comes first? E from ethyl or M from methyl? I'm sure you would say E from ethyl. So although methyl comes first by the number, but you need to name ethyl first. So you call it 3 ethyl. And then where's methyl? On the second one, 2 methyl. And what is the rest? A pentane. So you see, for numbering closer to the branch, for naming alphabetical order. So you can work on 2-methylhexane and 2 and 3 dimethyl for 3-butyl heptane. Let's work it together on the next slide. Two-methyl hexane. That's a, I'll give the IUPAC name for each of them. All right. I thought we were going from name to the structure. Then CH2, 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 and CH3. So what is the first step? Determining the longest chain. 1, 2, 3, 4, 5, and 6, or 1, 2, 3, 4, 5, and 6. So we go by 6, but should we go from top to the bottom or bottom to top? From top to bottom, because you have a methyl branch which falls on the second carbon. So you would say 2-methyl. And a hydrocarbon, an alkane with 6 carbons, is called hexane. Hexane, right? And the next one is CH3, CH2, CH2, CH. On this carbon you have a C, CH3, 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 and you have a CH3 here, CH, CH3, CH3. So again, let's determine the longest chain. Seems like we have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, no. 1, 2, 3, 4, 5, 6, no. 1, 2, 3, 4, 5, 6, no. So we have 7 carbons, but left to right or right to left gets to the branch faster. And we should have memorized the branches really well. What do we have on the second and on the third one? You have 2 methyl groups, methyl group, right? And on the 4th carbon, you remember this big guy? This is called tert-butyl or just T-butyl. So M comes before T, so we have 2 and 3. Both of them are the same. Separate them with comma. How many methyl groups? 2 methyl groups. So we have to show it. Dimethyl. Is there any other branches? Yes. Where? On the 4th carbon, 4. What is it? T-butyl. And what is the name of the chain? Heptane with 5 carbons. Okay. The next one on slide 52, that's good that we're going from name to the structure. So far we just worked on the structure to name, but you need to be ready for both, either from name to structure or structure to name. We are supposed to draw 2 and 3 and 5 trimethyl hexane. Whenever we are going from name to the structure, we always check the end of the name because we want to know how many carbons we need in our skeleton, in our longest chain. 6. So put 6 carbons first, a little bit distance from each other. Okay, 6. Now, what do you have as a branch? On the 2nd, 3rd, and 5th, you have 3 methyl groups. Tri is 3, right? 3. So 1, 2, 3, 4, 5, and 6. On the 2nd, on the 3rd, and on the 5th carbon, you have 3 methyl groups, right? Anything else? No. So now at the end, go ahead and complete the 4 bonds by adding enough number of hydrogens. 1 bond, so it needs 3 hydrogens. 2 bonds, 3 bonds, so it needs just 1 hydrogen. 3 bonds, 1 hydrogen. 2 bonds, 2 hydrogens. And 3 bonds, 1 hydrogen, and 1 bond, 3 hydrogens. was a good question. For alkenes and alkynes, okay, yeah, I will explain it later. So for alkenes and alkynes, we have a little bit difference in naming. So we are done so far with alkanes. For alkenes and alkynes, we need the first couple of rules are different. So we go with the longest chain, alkanes and alkenes, alkanes and alkynes. We go with the longest chain that include double and triple bonds. We said in alkenes we have a double bond, we have one or more double bonds, and in alkynes we have triple bonds, right? So the longest chain that has double bonds, like for example, if you have this, the longest chain is this, and priority is with double bond. Priority, double bond over branch. What does that mean? Means start closer to double or triple bond. I say double or triple bond because I'm talking about both alkenes and alkynes. All right, so which way is closer? In this case, none of them. So if you consider from left to right or right to left, they both have, does it? Yeah, it's different, sorry. It's if you number from right to left, then the third carbon is going to have the double bond, but you need to number from left to right, so the beginning of double bond will be on the second carbon. So now first name and number the branch in naming, and then double bond. So in numbering, double bond comes first. In naming, you mention the branch first, as usual. We always name the branch first. What is it? A 3, and it's a methyl group on the third one, between which two carbons you have double bond. It started from carbon number 1, so it's 2. If it was an alkane, you would have had pentane, right? Pentane. Now it's an alkene, so instead of A and E, you have E and E. So instead of pentane, you have pentene. So you have a pentene, you have 5 carbons. 2, it shows the location of double bond, for double bond. And you have a methyl group on the third carbon. Okay? 2 is the location of double bond between second and the third. So the carbon that starts double bond is going to be mentioned. And yeah, you just priority is with double bond, and the same for triple bond. I am working on slide number 57. We have good examples. Let's now name the first one, CH3, CH3, CH, CH3, CH2, CH3. So let's determine the longest chain that contains the double bond. If you go with a straight chain, it would be 1, 2, 3, 4, 5. If we go with this chain, non-straight, we'll have 1, 2, 3, 4, 5, 6. I told you the longest chain is not necessarily straight. And going from left to right, we are closer to either double bond and to both double bond and the branch. So 1, 2, 3, 4, 5, and 6. Now let's not name the branches first. What are your branches? A methyl group on the second and also a methyl group on the fourth. So you would say 2 and 4 dimethyl. Okay, and where is the location of double bond? You have on the second one 2 hexene, right? 2 and 4 dimethyl, 2 hexene. And in part B, you have 1, 2, 6, 7, 1, 2, 3, 4, 5, 6, and 7. And here you have, okay, the longest chain including double bond is which one? 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Either way. So number from closest to the double bond, 1, 2, 3, 4, 5, 6. So what is your branch? Is this, what was it? With 3 carbons coming from propane is propyl. So you have 3 propyl, 1 because the beginning is on the first one. 1 and the 6 carbons is hexene. Okay, make sure you have enough practice on these. For the alkynes, the same exact rules as alkenes, but you just work with triple bond and the ending should be Y-N-E. So on slide number 58, you have CH3, CCH. In each case, every single carbon must have a complete octet. So you have the location of triple bond. Even if you don't mention it here, it's okay because you don't have that many choices, but that's fine since it is mentioned on your PowerPoint slides. Where is the location of triple bond? Exactly the same. Location of triple bond, longest chain, it's very simple, so it's 1. If it was an alkane, you would have called it propane. But this is an alkyne because of triple bond, alkyne, Y-N-E, so it's propyne, Y-N-E. And the second one is CH, C, CH, CH3, CH2, CH3. Longest chain including triple bond, 1, 2, 3, 4, 1, 2, 3, 4, 5. And this is the closest to triple bond. So 1, 2, 3, 4, and 5. What is the branch? It would be this one, right? A methyl group. So there is a branch on the third carbon. It's called 3-methyl. And where is the location of triple bond? On the first one. 1 and 5. Instead of pentane, you have pentyne because it's an alkyne. Okay? And finally, naming aromatic compounds. Naming aromatic compounds. We said we work also on aromatic compounds. First of all, I told you need to know the name of this compound, which is benzene. And if you have any branches, just one branch on the benzene, you just call it the name of the branch followed by the word benzene. If you have, this is ethyl, right? You call it ethyl benzene. Okay? If you have methyl, you call it methyl. And you don't have to mention the location because you just have one location, right? Or if you have, like, for example, let's say you have chlorine, okay? You call it chlorobenzene. Whenever you have chlorine, bromine, iodine, you name them as chloro, bromo, iodo. Now, what if you have more than one substituent or more than one branch on the benzene ring? Depending on where they are, if we numbered this carbon number 1 and this is carbon number 2, it's 1 and 2 dimethyl benzene, right? 1 and 2 dimethyl benzene, correct? Because this is benzene and you have methyl groups, 2 of them on the 1 and 2. Instead of 1 and 2 di, you call it ortho. Instead of 1 and 2, you call it ortho dimethyl benzene. Or more abbreviated, if you need to use it, it's just O. Dimethyl benzene means ortho, means 1 and 2. So for di-substituted, or when you have 2 branches, we normally do not bring the numbers. We go with the ortho. If you have your branches on the first and on the third, then we'll have, instead of 1 and 3, you name it meta dimethyl benzene, or just by the first letter M, dimethyl benzene. And finally, if your branches on, I have to put it here, if you have them on the first and on the fourth, so then you have 1 and 4 dimethyl benzene, or you call it para dimethyl benzene, or just P, dimethyl benzene. So I want you to know the difference between ortho or O, meta or N, and para or P. So when you have, especially when you have 2 similar branches, 2 methyls, 2 ethyls, 2 propyls, you use this system. Now let's work on slide number 61. Let's draw 1 ethyl, 3 methyl benzene on slide number 61. I told you, whenever you go from name to the structure, you look at the ending of the name. There is a benzene. So let's draw it here. We have another example. Draw a benzene and call one of these atoms, one of the carbons, carbon number 1. What do you have on number 1? An ethyl group. You should have memorized the ethyl group, CH2, CH3. We said ethyl is connected from the CH2 part, right? And then a third methyl group on the third carbon. Where is the third carbon? Either here or here. Let's call it here. So on the third carbon you have a methyl group. So you call it CH3. Or let's say when you have 1 and 3 and 5 tri methyl benzene. Then again, you need a benzene ring. And on the first, let's say, this is the third and this is the fifth. You're just numbered like 1, 2, 3, 4, 5, 6. 1 and 3 and 5, and all of them are methyl groups. That's as far as you need to know for the benzene rings. You on the slide number 62, you have diphenyl methane. Don't worry about it; it's too much. Last part, working on slide number 63, derivatives of hydrocarbons. We worked on the main categories of hydrocarbons so far, but what if we have other atoms like oxygen, nitrogen, sulfur, chlorine, bromine on them? So we have some derivatives of hydrocarbons. And it's time to introduce functional group concept to you. A functional group is the reactive portion of the molecule. Reactive portion of an organic molecule. Okay? So only alkenes do not have, all capital letter means, hey people, alkenes do not have functional groups, but the rest of the compounds they do. That's why we said alkanes are not very reactive. You either need to substitute a hydrogen or just burn them in oxygen. But let's move to pages 64 and 65, slides 64 and 65. And functional groups are given, some famous functional groups, and those are the functional groups that are given in the exam. For example, if you have RCl or RBr, R is the alkyl group. R is the combination of carbon and hydrogen, okay? Well, either like, it can be CH3Cl or a lot of carbons and hydrogens. So we just call it with R, we show it with R. So if you have RCl, RBr, you call it organic halide. Again, you don't need to memorize all of them. You have this table in the exam. If you have, for example, OH attached to carbons and hydrogens, then you have an alcohol. So what is the role of functional group? It's the reactive portion. So first of all, the names, the properties, and finally the reactions of these compounds is because of their sensitive location. So the groups or atoms that are printed in blue in that table are the center of the reaction for that group. Like you have aldehyde, you have ketone, carboxylic acid, ether, ester, amine, and amide. I expect you to look at them to see the difference, which one has a double bond, which one has a single bond. The fact that you have the table in the exam doesn't mean that you shouldn't look at it before the exam. I want you to be familiar with it, and for the exam, if you are supposed to find out anything about the functional groups, then you have it. For example, if I ask you what is, for example, this, what functional group does this compound have? Just look at, I give you a hint. Look at slide number 64. I told you any combination of carbon and hydrogen is called R, huh? So it seems like you have ROR. What is it? Ether. So So that's what you needed to know. Work on the review questions about organic chemistry and let me know if you have any questions. Good luck.